1/3. See, it's not even all the way to -1 there. And this is the half, and this is the 4. The 3 places that function hits 0. The zeros of that function. X to the 3rd power function can have at most 3 zeros. All right, let's try number 3. Same kind of steps. So step number 1. Graph at desmos.com. So you graph it at desmos.com and get clear 0. So here's the graph. I've already graphed it at desmos.com and got for us a snapshot from that graph. Where is there a clue? This looks like it's something close to -1, but it's hard to tell. This is 1, 2, 3, 4. It looks like it's hitting twice here. You'd have to blow up the graph at Desmos, but I think it's hitting right there and then straight on 3. So there's a straight on 3, and then there's something just a little less than 3, it looks like. Let me kind of put that back there. There's right on 3, and then there's something a little less than 3. So I'm just going to take the one that's clear. Right on 3, x equals 3. That's a clear 0 from the graph, clear. Step 2, divide with synthetic division. So you put the 3 out there, and then you put the coefficients of our function. What are the coefficients right here? 1 and -5 and 4 and 6. And then bring down the 1 and let the division begin. So 3 multiplied by 1 is right there, 3. -5 plus 3 is -2. Whoops, going for the wrong thing here. Next, I'm going to take that 3 and multiply. 3 times -2 is -6. 4 minus 6 is -2. Last step, 3 multiplied by -2 is -6. No surprise, 0 remainder. That tells us that the 3 goes in perfectly and that the 3 really is a 0. We were reading that graph correctly. That's exactly a 0 because it goes in with 0 remainder. It goes in perfectly, which means it's a 0. 0 remainder means it's a 0. Okay, so now on step 3, so now right now we have the function y equals, what are the coefficients that are left? 1x squared minus 2x minus 2. And x minus 3. Remember, opposite of positive 3. Whenever you put something in parentheses next to x, it's the opposite of the real number. So it's minus 3. So we have the function broken down that far, so far. And now we're going to break this part down with the quad. So here we go, quad time. It's always step 3, negative b plus or minus the square root b squared minus 4ac all over 2a. So we have here's the a, here's the b, here's the c. So negative 2 plus or minus the square root of b squared minus 2 squared b squared minus 4 times a times c, which is -2 all over 2a. Okay, what's that? So we got double negative here. You know that's going to be positive 2. Let me change the color so it's clear. So positive 2 plus or minus the square root of -2 squared is positive 4. Minus 4 times plus 1 times minus 2. Remember, count the minus signs. 2 negatives, it's plus 8, isn't it? All over 2. So that is 2 plus or minus root 12 all over 2. Now, we can't square root 12. At least it won't be a nice clean whole number. How do we deal with the square root of 12? Remember, I'll bring it over here. Square root of 12, remember you break it down. 4 times 3, 2 times 2 times 3. Those are the pieces of a 12. So in other words, the root of 12 is the root of 2 times 2 times 3. And what do square roots do? 2 for 1 deal. But by the way, this is a 12, right? 2 times 2 is 4. 2 times 2 is 4 times 3 is 12. That is a 12. Square roots do a 2 for 1 deal. 2 2's inside, 1 2 outside. So 1 2 on the outside, 1 3 left on the inside. So 2 root 3. So square root of 12 is 2 root 3. So this is 2 plus or minus 2 root 3 all over 2, that root 12. Okay, let's bring it over here. How do we simplify that? Can I cancel like those 2's like that? Well, not just those 2's. Remember, the plus or minus here is glue. It makes these guys be glued together in a package deal, right? Costco glue, the plus or minus is like Costco glue, gluing them together. So as long as you buy the whole package, though, Costco will sell you the whole package. You just got to do both of them. So basically, here's the deal. If all 3 of those outside the root numbers, if they're all divisible by 2, let me put it back the way it was, then, or whatever number, you can do it. They have to be all 3 divisible by the same number, and they are, right? They are in this case. This number, this number, this number. Divide by 2 leaves a 1. Divide by 2 leaves a 1. Divide by 2 leaves a 1. So it's 1 plus or minus root 3 over 1. We don't need 1's on the bottom. Dividing by 1 does nothing. So our answers are 1 plus root 3, comma 1 minus root 3, and the answer we had from the beginning, plain 3. Those are the 3 answers. Those are the 3 zeros. Everybody see how this works over here? If all 3 of those numbers are divisible by the same thing, then you do it. Now, if one of them couldn't, like if this had been a 3, for example, he's not divisible by 2, then I would do nothing. I would just stop right here. I couldn't divide anything. It's all 3 of them or nothing. All 3 have to be divisible. All 3 of them have to be divisible by the same number. All 3 of them were divisible by 2, so I divided them all by 2. Got 1 plus or minus root 3 over 1. Divided by 1 does nothing. Get rid of that. So it's 1 plus root 3, 1 minus root 3, and the original 3. That matches the answer right there. Those are the 3 zeros. Those are the 3 places. If you did this on your calculator, 1 plus root 3. Let me see, I'll do it on my calculator too. See, 1 plus square root 3, if you're interested, that's 2.7, 2.73, blah, blah, blah. And 1 minus the square root of 3 is negative 0.73, blah, blah, blah. So this looks like negative 0.7, doesn't it? And this looks like 2.7, and of course that is 3. So those are the 3 places where that function hits 0, has a height of 0. Those are the 3 zeros. Good. Okay, well, I'm going to skip number 4. This one's just the same as the other ones. I've got the graph there. I'm going to go on to number 5. This one's a little different, so let me do this one with you. So you know step number 1, you graph it at desmos.com. Find a clear 0 from the graph. So on the exam, what I'll do is I'll give you a snapshot of the graph because you can't go on the internet for your graph. So I'll give you a snapshot of the graph on the exam. So, all right, so